Hello, students. So here is the corrections for the quiz that I should have administered to you, right? So here's the first question. The diagram is a speed time graph of an MRT train which travels from rest at station A to rest at station B, right? So it accelerates and then after that it slows down. Okay, so the train reaches greater speed at 20 meters per second as it passes through point P. So the point at which the speed is the highest and then after that it starts to slow down is a point P. We're going to just call it point P. 80 seconds after traveling, after leaving A. The whole journey is 28 seconds, right? So that's the whole journey. So we are told to calculate the number of seconds after leaving the station A. That is speed is 12 meters per second. So okay, so how do we do that? Well, we can actually make use of the concept of proportionality, right? So how does it look like? Okay, we zoom in a little bit to the first part of the journey. This is the triangle you can see I have on the left side of the screen. So we are going to let the number of seconds be A because so at point A, the speed is actually 12. So we can do a quick sketch of the triangle, and you can see that by making use of the similar triangle, proportionality of similar triangle, we can say that A over 12, right? A over 12 is going to be the same as 80 over 20, right? A over 12 is the same as 80 over 20. Can you see the proportion there of triangle? I hope you can, right? So let me say one more time. The A is actually the horizontal distance of the small triangle on the bottom left. So the horizontal length, and then 12 is the vertical height, right? So that is proportional to the larger triangle. So where the horizontal length, the base is 80 and the height is 20. Okay, so by working out this proportion, we can figure out that A is actually 48 seconds, and that's when the speed is 12 meters per second, right? Next, we are told to find the distance AB. So the distance AB basically is the area under the triangle. So we just make use of the formula for area of triangle, half times base times height, and quite easily obtain the value 2,800. Okay, right. So part C. Part C, the question asks, right, the number of seconds after leaving A, that the train is 80 meters away from B. So now we are actually working backwards from the end, right? So what is the time that we need to find, right? So 80 meters from B. So the second triangle on the triangle on the right, rather, okay, we're going to sketch it out just to give us some clarity of what we are trying to do here. And we're going to let the number of seconds be x. Okay, why not, right? So the speed at which it will be at will be y. So we're just going to define in this way. Okay, so by doing this again, by making use of the proportionality of similar triangle, we say that y, okay, y is actually the height of the smaller triangle, the over the base of the smaller triangle, which is 280 minus x, okay, is equals to the height of the big triangle, 20, over the base of the big triangle, which will be 280 minus 80. In this case, it will be 200, right? So we have that equation. We simplify it. We'll find that y is equals to 280 minus x over 10. We leave it there first because there is another piece of information that we have that we can use, right? And the other piece of information will be the um, distance is 80 meters away from station B. So this tells us that the smallest triangle on the right of the diagram, right, is going to be 80 units, right? So we go half times base times height. So half times base, the base of this small triangle on the right is 280 minus x, right? And the height is y. So half times base times height equals 80. We simplify this, we'll end up with y equals to 160 over 280 minus x. So here we have a pair of simultaneous equation, right? X and y, equation 1, equation 2. But since we have already written it in such a manner where y is a subject, we can just equate them, right? So equation 1 equals equation 2, or rather y equals to y. So we have this 280 minus x over 10 is equals to 160 over 280 minus x. So I cross multiply it. We have 280 minus x squared equals to 1600. So that tells us that 280 minus x can either be 40 or negative 40, right? Because 40 squared gives us 1600, negative 40 squared also gives us 1600. So from here, we work out x equals to 240 seconds. The other one doesn't work, right? The other one, we have 280 minus x equals to negative 40. So that gives us x equals to 320 seconds, which is more than 280, right? So we will reject it because the value of x should not be more than 280, which is beyond station B, right? So the solution here is actually 240 seconds. Okay. Right, continuing. The second question, we have a diagram that shows the speed time graph object A. The acceleration for the first 20 seconds is 1.5, right, meters per second squared. We find the value of V. So this is just a simple question to test our basic understanding of concept of acceleration, which is the gradient of a speed time graph. So gradient, rise over run. So in this case, the rise is V, the run is 20, that is equals to our acceleration 1.5. So that works out to V equals to 30 meters per second, right? Now the second question, right? Let me go back. It says that the retardation, okay, retardation is another word for deceleration, right? It's the same thing. Is twice as great as the acceleration, which means the triangle on the right side of the graph, the steepness of this slope, right, the gradient, is going to be twice, okay, of the acceleration. So how does it work again? So we use the rise over run. So V is the rise. So V over t minus 40, which is the run, okay, is going to be twice the acceleration. We know that acceleration is 1.5, it's given in the question. So that gives us, and we also found that V is 30 from part A. So 30 over x minus 40 is 3. Simplify this, we get t equals to 50 seconds, right? So that's where the end of the journey is at time equals 50 seconds. So finally, we are told to find the average speed. Once again, remember, average speed must be total distance divided by total time. So the total distance in this case is the area of the trapezium. So just apply the formula for area of trapezium, half, then the sum of the two parallel lengths times the perpendicular height, right? We get 1050 meters. So average speed will be total distance 1050 meters divided by total time is 50 seconds. We get 21 meters per second. Okay. Right, next question. Next question, we have another speed time graph. This time round, there's a car and there's a motorcycle. You can see here the car start moving first. After some time, the motorcycle also start moving, right? We are told to calculate the acceleration of the motorcycle. So that's great. Motorcycle is a single straight line with constant increase, okay, of the speed. So that tells us that the acceleration will just be the rise over run, and we can do that, right? So the acceleration rise over run 60, okay, which is the rise. Why do I not use 90? Well, because I do not know the time, okay, when the motorcycle is at 90. So because the gradient is constant throughout the entire journey, I just look for another point that I have both the x value and the y value, right? And that will be at 60, because at 9 seconds is 60 meters per second. So I can use this point instead, right? So it works just like the one of the questions in your assignment earlier. Same concept, right? So we can use this 60 over 9 minus 3. Why minus 3? Because the starting point is 3. So the run is actually between 3 to 9, which is only 6 units. So that gives us acceleration 10 meters per second squared. For part B, what happened? Part B, they are saying that, okay, the two vehicle, the car and the motorcycle, they actually meet. And we want to find the time where they meet, right? Because at this point where they meet is where they also have the same speed. So how do we do that? Well, let's take a closer look. Okay, I actually sketch out this motorcycle portion, the triangle, to help us to visualize. Okay, I'm just going to do the gradient in this case, right? Because the acceleration is constant throughout. So by making use of the gradient, okay, in this time round, the smaller triangle up to 40, the rise is 40, right? The run, okay, is going to be the time that we want to find. So let's call it t minus 3. And this is equals to 10. So from here, we can work out that the time is actually 7. Okay, just by making use of the acceleration of the motorcycle, I can find this intersection point between the motorcycle and the car because I know that the speed is 40 at that point, right? So I can use that to help us. Okay, so the time where the two vehicles are the same speed, right, is 7 seconds. So in the third part, what happened this time round? Okay, let's pull back just in case we forget. They say, okay, when the motorcycle is traveling at the speed of 90, okay, and when reach there, what happened? Okay, it starts to overtake the car. So over here, okay, when the at the very end of the diagram, on the right side of the diagram of the graph, okay, there's this is where the motorcycle starts to overtake. So what do we understand when we overtake? Well, in order to overtake someone, you actually travel more distance than them, right? So what this means is that at that point, okay, at that point of the graph, the distance for the motorcycle is the same as the car. And then after that, when you go forward, the distance of the motorcycle will be greater. So that's what we're going to do. We're going to find the distance, right? So the distance of the car, traveled by the car is going to be the same as the distance of the motorcycle at that point. So we're going to let that point, the be x seconds. We can use any letter you like, but x is fine, okay? So but we're going to use the area of the under the car, the journey by the car. So we start with the triangle, right? On the left, we have half times 3 times 40. That's the first triangle. Then we have 6 times 40, which is this rectangle. This is the rectangle in the center. And then on the right side, it is a trapezium. So half times the 40 plus 30, which is the parallel length. And the vertical perpendicular distance is x minus 9, right? That's for the trapezium on the right side. So that is equals to, well, the area of the triangle for the motorcycle. So half times base. The base is x minus 3. The height is 90. Okay. So from here, we obtain our equation. Now very carefully simplify it, and we will finally reach the value of x, which is equals to 12. And so after 12 seconds, that's when the motorcycle actually overtake the car. All right. And so these are the solutions to the questions that I gave you for your quiz. Hope you have done well, and if not, well, don't worry too much about it. Learn from our mistakes. Okay, do the correction thoroughly, and just learn from our mistakes and remember the important concept that is being taught here. Okay, have a nice day.